Welcome. This is a time series analysis course. My name is Nicoleta Serban. I'm Associate Professor in the Stewart School of Industrial and System Engineering. This lecture is on other time series methods. And in this lesson and the one following, I will conclude this lecture and this course with a general modeling framework that for multivariate time series called functional data analysis. The models discussed so far are all linear models in the sense that they capture linear dependencies with respect to the past history of the time series. A framework which allows estimation of non-parametric relationships and dynamics between time-varying processes is the so-called functional data analysis. Functional data are defined as multiple processes or so-called random functions which depend in our context on time, although they can depend on other functionality designs, for example, space. We have n such random functions or time series, each one observed at a set of time points denoted here Tij for the ith random function or process. The time points do not need to be the same across all the random functions. We can also have a fixed design when the time points are fixed in advance, but also random when we have observations of the random functions at random time points not known in advance. Last, unlike time series analysis, the time points can be observed sparsely or densely, depending on the experiment generating the random functions. The field for analyzing such data is called functional data analysis. These are examples of such functional data. The two examples on the left are for sparse design of time points, whereas those on the right are for densely observed time space or dense design of time points. The difference between the examples of functional data displayed on the top versus on the bottom plots is that those on the top have a random design, whereas those on the bottom have a fixed, equally spaced design. Within each of the four plots, each line crosses the functional observations sampled from two different random processes at varying time point. The two processes differ in the mean and the covariances matrices. The observations can be made sparsely or densely over the time period, and they can be made at time points with a fixed, equally spaced in this case design, or at random time points over this time period, as illustrated in those four examples. We can add random errors or disturbances to these functions and thus obtain the functional data as provided on the slide. Similar characteristics in terms of the design points are for this functional data. However, because of the random disturbances, we see that the patterns of the functions are less clearly distinguished, particularly for the sparse design. The idea of functional data analysis is to borrow information across multiple such random functions to make inferences on the process generating the functional data. This is particularly the case when the design of time points is sparse and or the functions are observed with high measurement error. Thus, the difference between classic time series analysis and functional data analysis is that in classic time series analysis, we draw inferences on a time series given past history alone, whereas in functional data, we make inferences with the aid of repeated realizations of the same or similar processes. General characteristics of functional data are as follows. Functional data are measurements or realizations of smooth processes over time plus noise, thus with no drastic change points or discontinuities. They are commonly non-stationary processes with time-varying first moment or second moment. And in fact, the focus is on estimation of the first and or second moments of the generating functional process. We usually do not want to make parametric assumptions about those processes. We use non-parametric or semi-parametric approaches to estimate the first and second moments of the generating process. Often we have multiple measurements of the same process or repeated measurements of multiple processes, also called multi-level functional data. In the analysis of functional data, we study the distribution of the process generating the functional data along with the relationships between functional random variables and relationships between functional random variables and other quantities. Functional data analysis methodology has focused on many areas of research. For example, two of the most common objectives are representing the data in ways that aid further analysis through functional clustering, or studying important sources of pattern and variations among the data through functional principal component analysis. Functional data can often be observed shifted in time, and thus alignment or registration of the functional data can be used to display the data to highlight various characteristics of the generating process. Methods for explaining variations in an outcome or dependent variable by using independent variable information, such as functional regression analysis, is one of the largest areas of methodological development and application, since it can capture relationships and associations between complex processes. For example, one may extend the linear regression model to the so-called time-varying regression model, in which the regression coefficients are not constant, but are functions varying in time. Such models can capture relationships between a response variable and multiple time-varying predicting variables. Functional data analysis is now a very active field. You'll find many methodologies already implemented in our statistical software. In the last lesson of this lecture, I will briefly illustrate functional data analysis with one specific methodology. In summary, in this lesson, I introduced yet another statistical modeling framework, so-called the functional data analysis. Thank you.